Hey everyone, I hope everyone's okay. I hope you're keeping safe and well. Welcome back to the second chemistry lesson. We're going to do another revision lesson today. As ever, you are going to need your periodic table. If the thought of chemistry makes you extremely happy, you're welcome to also copy the dance that you can see on the screen. I'm not going to judge. But yeah, chemistry, always going to need a periodic table. Other things as well that you're going to need your chemistry book, your stationery equipment, including pen, pencil, rubber ruler, highlighter, and calculator. Remember as well, please, that this lesson should take you an hour at the most. So I don't want you spending hours and hours and hours and hours on this one chemistry lesson. If you do find that you're struggling and it's taking you a lot more than an hour, then please email me with any questions that you have, and I'd be happy to help you with whatever you need. Other thing to remember as well, you need to write the information in the blue boxes. So from the work that I saw last week, we had a lot of students that were copying information that wasn't actually included in the blue boxes. So anytime you see something in a blue box, that's a signal to you that you need to copy it into your books. If you do not see something in a blue box, you do not need to write this down. Okay, it's going to save you a lot of time, and yeah, it'll be a lot easier for you. So only information in the blue boxes is what you'll need. However, do not think I didn't notice that some of you only looked at the notes and didn't look at the video. So some of the information from the PDF is going to be missing. You'll only be able to see it if you watch the video. So as we go through the video, I will fill in the information, the missing bits of information, and you can copy it as you go along. So please do make sure you watch the video as well, together with reading the PDF document. And finally, before we go on to the do now tasks, I just want to show you some really nice notes that we had from last week. This is something I'm going to hopefully do every week. So we'll pick out 2 examples of students who've done some really nice work from the previous week, just to show everybody really, and just to share how great you guys are doing in chemistry. So really well done for that, and keep it coming. So without further ado, let's go on to the do now task. So you've got 5 minutes to attempt these questions, a maximum of 5 minutes, and you may pause your video now to complete these questions. Okay, so by now you should have attempted all of these questions, if not all of them, at least one of them. So let's have a look at the questions and go through the answers together. So we've got the first question, looking at your periodic table, what group is lithium in? You will notice that it is on the left-hand side of the periodic table, and it's in the first column. So lithium is in fact in group 1. Well done if you got that one right. So second question, how many electrons are in the outer shell of group 1 elements? Now, if you remember what we learned, the group number tells you how many electrons there are in the outer shell. So group 1, because the elements are in group 1, they must have 1 electron in the outer shell. Well done for getting that one right as well. Right, now next question, looking at your periodic table, what group is chlorine in? So you will find that chlorine is actually on the right hand side of the periodic table, and it's in group number 7. Really well done for getting that one as well. And then finally, what kind of bonding exists in lithium chloride? And I've given you a hint here, thinking of metals and non-metals. So we know that lithium is a metal. We know that this is a non-metal. So if we have a metal and a non-metal, this results in ionic bonds being made. So the type of bonding is ionic bonding. Well done if you got those ones correct. Let's go on to the next slide. So what we're going to do today, like I said, it's another revision lesson. So we're going to go through group 1 reactions and trends. So this includes lithium, sodium, potassium, We're going to go through group 7 reactions and trends, so fluorine, chlorine, bromine, iodine, and then we're going to go through group 0 as well. So to start off with, let's remind ourselves what group 1 elements are. So you can see that I've put a picture there of all the different elements that are in group 1. So they include lithium, sodium, potassium, rubidium, cesium, and francium. And we know from what we've done previously that group 1 elements are metals. So we're just going to write out that they are metals. They are called alkali metals. That is the special name given for group 1 metals. They are in group 1, so they all have 1 electron in their outer shell, and as they go down the group they actually get more reactive. Let's cross that out. So just take a couple of minutes to fill in that information and copy down what you see in the blue boxes and press play when you're ready. Okay, so let's move on to the next slide. So for group 1, let's go through quickly just some of the physical properties of the different metals that you have in group 1. So if you can remember, all of group 1 metals are soft. You can actually cut through them quite easily, which is not something that you can say for copper and for iron and other common metals that you might think of. But group 1 metals are soft, they are shiny, they are solid at room temperature, they are conductors of electricity, and they have high melting and boiling points. So I'll just give you 2 minutes to copy this information down, pause the video and press play when you're ready to continue. Right, so the next slide, what we're going to go through is the reactivity of group 1 elements. Now, group 1 metals are very reactive. You can see from the picture there that you've got lithium, sodium, and potassium, and they're in containers, and you've got a liquid of some sort that the metals are stored in. This metal is, all these metals, sorry, are actually stored in oil. And the reason for that is that they're so reactive. If we left them out in the air, they will react with oxygen in the air. So group 1 metals are very reactive. They must be stored in oil, otherwise they will react with oxygen in the air. So take a minute to copy down the information in the blue box, press pause if you need to, and continue when you're ready. So let's have a look at how readily they react with oxygen. So you can see from this GIF, you've got a piece of lithium, and slowly the color is changing. So when the person first slices through the lithium, you can see it's got a really nice shiny silver color, but in the space of about 15 seconds, that nice silver shiny color slowly turns gray, and that's how quickly it reacts with the oxygen. So the nice shiny silver that you see is pure lithium. When it starts turning grey, that means it has reacted with oxygen to make lithium oxide. And you see this pattern continuing as well. So this is a pure piece of sodium. You can see that the person has sliced through the sodium. It's nice and shiny to start off with, but it very quickly reacts with the oxygen in air. In fact, this has taken, I think, 6 seconds compared to lithium, which took about 15 seconds to react. And then if we go further down the periodic table, we've got potassium. Now, potassium reacts so quickly that we don't actually get to see the nice shiny silver, because that's how quickly it reacts with the oxygen in the air. So you can see as we go down the group, we start with lithium, then to sodium, then to potassium. As we go down the group, the reactions get quicker and quicker and quicker. So how can we show this in the form of an equation? And it's very straightforward. You will remember this from the lessons that we did before the Christmas holidays. Reactions with oxygen, lithium plus oxygen, it forms lithium oxide. Very straightforward reaction. Lithium plus oxygen react to make lithium oxide. So I'm going to give you 3 minutes to copy down the information in the blue box and see if you can write the missing bits of information before we go through them together. You may pause the video now and continue when you're ready. Okay, so welcome back. If you've had a go, so we can see lithium plus oxygen makes lithium oxide. So let's do the same for sodium. Sodium plus oxygen makes sodium oxide. Well done if you got that one correct. And finally, for the reaction with potassium, you can see that the product has got the name potassium in it. So we must have started off with potassium and reacted it with oxygen to make potassium oxide. Really well done if you got all those correct. And as an extension question, if you're up for it, I've given you a balanced symbol equation for the reaction between lithium and oxygen. All the numbers in there are correct, whether it's the big ones or the little ones, all the symbols are correct as well. And if you would like, just to challenge yourself, you can write the balanced symbol equation for the reaction between sodium and oxygen. Right, so let's move on. So what we're going to do now is going to look at the reactions of these metals with water. So we've already looked at the reactions of lithium, sodium, and potassium with oxygen. Now we're going to look at the reactions with water. So you can see in this example, when lithium, small amount of lithium is placed in water, it moves around. You can see some bubbling, you can see some fizzing, and you can actually see some steam there as well, which suggests that a lot of heat is released in this reaction. Going on to the next slide, if we place a little bit of sodium in water, the sodium also moves around the water. It actually moves around quicker than the lithium, which isn't apparent from this video. But again, you can see some fizzing, you can see some steam, which suggests again that the reaction is producing a lot of heat. Now, when we place potassium in water, you can see straight away that you get a really nice bright flame that's produced. And it's actually a lilac coloured flame. So in the reaction with potassium, you get a really beautiful coloured flame. It's lilac in colour. And this reaction, it's a lot more rigorous. So where we had the lithium and the sodium moving around a little bit, potassium moves around really quickly. The reaction's more rigorous and you get a really nice lilac flame that's produced as well. Going further down the group, you can see with the rubidium, this reaction is extremely rigorous. So just putting the rubidium in the water, it reacts almost straight away. Yeah, so very rigorous. And then if we go further down the group with cesium, the trend continues. So the reactions get more and more rigorous until eventually, if you put a small piece of cesium into water, the reaction is that rigorous that it actually breaks the container, as you can see in this example. So we've got a general trend that we can notice in our reactions of these group 1 metals with water. So let's look at the products that are made when these group 1 metals react with water. So you can see from the first example, we've got lithium plus water makes lithium hydroxide plus hydrogen gas, which is produced. Now, group 1 metals all react in very, very similar ways. So the reactions that you can see happening, even though they get more rigorous down the group, you're going to have very similar products that are going to be made. So your word equations are also going to be really similar. So if we've got lithium plus water makes lithium hydroxide and hydrogen, if sodium reacts with water, we get sodium hydroxide plus hydrogen gas. If I can spell it, hydrogen. And then finally, if potassium reacts with water, going to follow a similar pattern. Instead of making sodium hydroxide, you make potassium hydroxide. And you also make hydrogen. Okay, and the hydroxide is what makes something alkali. So if you remember from the beginning, we said that group 1 metals are called alkali metals. This is where they get their name from. So I'm going to give you 4 minutes. You may pause the video and you can copy down all the information that you see in the blue boxes and press play when you're ready. Okay, so another extension question if you're up for it. I have given you the balanced symbol equation for the reaction between lithium and water, which is shown in front of you. And I ask you, what is the balanced symbol equation for the reaction between sodium and water? Have a go. I will be checking your books to see if you had a go at it. You do not have to have a go at this question if you do not want to. If you fancy a challenge, by all means, please have a go. Okay, so some follow-up questions for you just to recap and test your memory of what we learned so far. So question number 1, how can we tell from the reactions with oxygen that the group 1 elements get more reactive going down the group? Question 2, which gas is produced when lithium reacts with water? And question 3, what will you see when potassium is added to water? So you will see a specific coloured flame and you will see something else. So 3 minutes. You may pause the video and press play when you're ready. So that was it for the group 1 metals, the little bit of revision that we did for all of those. Well done if you got those questions correct. Now we're going to go on to group 7. So group 7 elements include fluorine, chlorine and iodine, as you can see on the image on the right of the screen. Are they metals or non-metals? So we know that group 7 elements are found on the right hand side of the periodic table and they are metals. They have a specific name for them. They are called halogens and they are diatomic, which means they go around in pairs. They all have 7 electrons in their outer shells because they are in group 7, and unlike group 1 elements, these guys get less reactive going down the group. So you have 3 minutes, take as much time as you need, up to 3 minutes, to copy down the information in the blue box in front of you. You may press pause and continue when you're ready. Okay, so let's fill in this table. I know that the table isn't color-coded in blue, but you do have a blue box around it, which means you need to copy this information into your books. So if we look at the formula of all the different group 7 elements as we find them in their natural state, so how we find them as they exist in nature, fluorine exists as F2, it's diatomic, it goes around in pairs. Chlorine is exactly the same, so the formula for chlorine is Cl2. Bromine, exact same, Br2, goes around in pairs. Iodine, the symbol for iodine is I, iodine goes around in pairs. And then you've got astatine as well, which we don't really learn too much about, but that also goes around in pairs. So then if we look at the colours, rather than writing the colour, if you've got some colouring pencils, you can just fill in the block where the colour is shown. So for fluorine, it's a really nice pale yellow colour. For chlorine, you have a pale green colour. Bromine is orangey, orange. Iodine is purple. And astatine is black. And then if we look at the state of all of these elements at room temperature, fluorine at room temperature is a gas. Chlorine is also a gas at room temperature. bromine at room temperature is a liquid. So one of only two elements on the whole periodic table that's a liquid at room temperature. The other one is mercury. Iodine is a solid at room temperature. And finally, so is astatine. So you may pause the video now and press play when you're ready to go on to the next slide. So what reactions do we have to know for group 7 elements? We need to learn about displacement reactions. A more reactive element will kick out or displace a less reactive one. So how does this work? So a displacement reaction example is shown in the blue box. You've got sodium bromide and you've got chlorine. Now, if I look at my list of group 7 elements on the right here, I can see that chlorine is above bromine, which is here. And we said at the beginning that the most reactive ones are at the top, and the elements get less reactive as you go down the group. So the least reactive is this astatine at the bottom. So in our example of a displacement reaction, I've got sodium bromide and that reacts with chlorine. And I have to decide whether chlorine is reactive enough to kick out or displace the bromide. And looking at the list of elements on the right, I can see that chlorine is above bromine. So I know that chlorine is more reactive. So a displacement reaction does happen. So my product is going to be sodium chloride. We say chloride instead of sodium chlorine when it's reacted. And it also has bromine as a product. So is chlorine more reactive than bromine? Yes, it is. So the way that we phrase this, we say that the chlorine displaces the bromide. So you've got 3 minutes to copy down any extra information that you need to. And when you're done, go on to the next slide. So let's go through some practice questions. You have got 6 equations here, and I'm going to ask you if a displacement reaction occurs. What does that mean? I want you to look at the reaction and I want you to decide if the element on the right, like I've circled here, is more reactive than the one I have underlined, as you can see here. So let's go through the first example together. We've got sodium iodide and bromine, and we need to know if the bromine can displace the iodide. So we need to see if the bromine can essentially kick out the iodide. And the only way we can tell that is to see which one's more reactive. So let's make a note on our list on the right of which one was the most reactive. So if you remember, the most reactive one's at the top. It gets less reactive as you go down. So we've got least reactive written at the bottom. So let's compare bromine and the iodine. So you can see bromine is here and iodine is underneath bromine. So because bromine is on top, it's actually more reactive. So it will displace the iodide. So your product is going to be sodium bromide, and the element that got kicked out, displaced, we've got iodine. Okay, so have a go at the next question, see if you can do the same thing. You've got chlorine, that's the one you're checking, to see if it can displace the iodide. If you do not think it can displace it, if you think no, nothing's going to happen, it can't displace it or kick it out, you just simply need to write no reaction. Okay, so give yourself 5 to 6 minutes, and then we'll go through the answers together. So you can pause the video now if you want to have a go, and then press play when you're ready. Okay, so let's go through the answers. So for the second question, we had sodium iodide plus chlorine. We needed to see if a reaction took place. Chlorine is up here, iodine is near the bottom, so we can see chlorine is more reactive, so it will displace the iodide. So my product is sodium chloride and iodine. Right, for the next question, we need to see if chlorine is more reactive than bromine to see if chlorine can displace the bromide. So we can see that chlorine is up here, bromine is below, so chlorine is more reactive. So we're going to have sodium chloride and bromine as the products. Right, next question, we have some iodine and we've got some sodium bromide, and we need to see if the iodine can displace the bromide. So if I look at my list of halogens on the right, I can see that bromine is above iodine, so bromine is actually more reactive. Iodine is less reactive, so it cannot displace the bromide, so no reaction happens here. So we can just write no reaction. Right, and the next one, we've got iodine in the reaction, so sodium chloride plus iodine, and we need to see if the iodine can displace the chloride. And again, if we look at our list, we can see chlorine is near the top, iodine is near the bottom, so iodine is less reactive, so it cannot displace the chloride, so no reaction occurs. And finally, in our last equation, we've got sodium chloride plus bromine. We need to see if bromine can displace the chloride. Bromine is below chlorine, so it is less reactive, so it cannot displace the chloride. So again, for the last one, we've got no reaction. So well done if you got those right. If you need to make any corrections, you could do so. If there's anything on here that is a little bit tricky to understand, please feel free to email me and I'll go through it with you again if you need to. So let's move on to the final group on the periodic table that we have to learn about. This one's a really nice group. So group 0, the elements include helium, neon and argon, and they are on the right hand side of the periodic table. So you know if they're on the right hand side of the periodic table, they are non-metals and they are called the noble gases. And you can see just from the name that they're all gases at room temperature. And the reason why they're in group 0 is because they all have full outer shells. So every single noble gas here has got a full outer shell of electrons, and because of this they don't react. So take a few minutes to copy down the information and we'll continue when you're ready. And that's it, that's the end of the lesson. Really well done. So don't forget, you must take a picture of your work and submit it on class charts by the end of the day, and I will be checking like always. Any questions, please email me at shafiq@workinghigh.surrey.sch.uk, and I shall hopefully see you all next week. Bye.